about observability.
All right, hi everyone. So my talk will go directly after Jono's. And so everything you've learned there, we're gonna use and extend upon. So one of the things that's big right now is observability. So what is observability? Well, it's a really hot word and everyone wants to know more and they're trying to add it. But really it comes from control theory actually, which is it describes the ability to measure the internal state of a system from the knowledge and information you can gather outside of the system. So metrics, and so all of these things, metrics, health checks, tracing, access logs, if you've got specific application metrics or application logs. And so one of the things we're going to talk about today is specifically with tracing and layer 7. And so when we're dealing with failures, we have a lot of different kinds of failures that we can see. There's full systems failure, everything's down, nothing's responding. These are easy to find out. Your monitoring catches these and you will, or your customers will notify you. These don't go missed, but then some of them get harder. What if a single node has failed or is intermittently failing? Or you just have a single instance of your app services running that's failing. And so in order to figure out where your failures are happening when they're smaller, more intermittent, it's useful to be able to pinpoint the data that's causing those failures and see information about those calls. And so we'll show how you can do that with a couple different things here today. And then just to go into a little detail on layer 7, there's connections and requests. With the Envoy proxy that's running, your connection gets opened between the proxies and then that connection is left open. It's not reestablished every single time for every call. And then the different requests will flow over that existing connection. So that helps speed up things and reduce the ability or reduce the requirement to re-authenticate and ensure that that intention is there to allow those services to talk. And then failed requests don't always cause a disconnect. So that proxy could leave requests that connection open. Sometimes a failure could be the service died and that connection gets terminated. And then it's also really helpful to be able to see the status codes as well as gRPC methods names. And so we'll show how all of that data is available in the trace. And so what does this look like? So similar to what Jono deployed, we've got service A and service B running. They're each in their own pods inside of Kubernetes. And they've got that sidecar proxy deployed. And that was automatically injected by Consul for you, and Consul's running there in the cluster. And then also in your cluster, you can run, for example, a Datadog agent. And so your applications will emit metrics and traces to the Datadog agent. The sidecar proxies will emit metrics and traces to the Datadog agent. And then that agent will forward those over to Datadog so you can see them in their dashboard. You can also use tools like Zipkin and Jaeger, which I will also show today in addition to the Datadog demo. And then one thing that's really important to keep in mind, the service mesh is not a silver bullet. This will add some observability and give you a lot of insights into the network calls and traces that are happening in your network. You can do authentication, you get zero trust networking. You get a lot of things with service mesh, but it's not going to solve every problem you have. And it's not going to be able to do some things you might want to do. And with that, let's dig into the demo because demos are more fun than slides. So let's go ahead and jump over here. And so what we have is we've just checked out a Consul demo tracing repo that we actually have up on the HashiCorp GitHub. And so what is in here is we have a Consul config. There we go. And so if we look here, we can actually see that this is a full config file for a Consul server. It'll be passed into the container running Consul. So we're setting our data center, we're setting ports that we want to listen to for gRPC, we're enabling connect, similar to everything Jono did before. But we now added telemetry for dogstat-d and we give it an endpoint. And then farther down, we also configure an Envoy dogstats-d URL so that our Envoy sidecar proxies are sending their data. And then we add a static cluster config that defines an endpoint for Datadog and where we can hit that here. And we define the name. And then inside, we now set up some Envoy tracing JSON, which is for HTTP, use Envoy tracers Datadog, and send it to that service we defined with the service name Envoy. And so that's all there is to that. Now, if we look, we can actually check out the central config that we're going to use within Consul. And we can look at our ingress. So by default, we're just defining our ingress with some defaults that the protocol is HTTP. And then we have our web defaults, which is defining it with the name web, and the protocol is also HTTP. But then we have our API service, and this one actually has a protocol of gRPC. So this will, since we're making sure Consul knows the different types of protocols that are being used for the connect, it can ensure it sets up the tracing correctly. So we'll get tracing for both our gRPC and HTTP requests. And now we can check out the service configs specifically for these. So for ingress, we're defining that this is our v1 ingress. It's listening on port 9090 on this IP. We're going to go ahead and set up a sidecar proxy that's listening on 2,000 or 20,000. And one of the things we want to be able to talk to is the web service that we defined. And we want to be able to talk to it on 9091 locally for us. And then we kind of do the same thing with both web. So web does the same basic setup, port 9090, but we want to be able to talk to the API service on port 9091 locally. And then our API service. So this one does not actually have any proxies because the API service isn't talking to any other services. So we're just defining the API service here. And so this is in the case where you're doing this without Kubernetes with the automatic connect injection and the annotations to make that work for you. So now this one's got a Docker Compose YAML. So what we have here, we've got our console image starting up first. So we're running Consul and we are passing it that console config that I showed. And then we're running a fake service, and this is our ingress service. So it's going to have an upstream URI of that localhost 9091, which actually goes back to the Envoy proxy, and we'll forward it. And then we set up some timings for 50th, 90th, and 99th percentile so we can measure that. And then we also add tracing and metrics for Datadog to our application. And this is because we've added the tracing and metrics into our application so that it can emit those metrics for us. And then if we continue down, we see more of the same. Here's our actual ingress Envoy proxy. And so we can see we're passing it config in. And then we've got our web service, and it's very much the same thing, other than its upstream URI is actually gRPC to localhost 9091. And this will hit the proxy and forward that request to the API. And then our web proxy Envoy instance is running here. And then last, we have our API service. And one thing to note here, the server type's gRPC now. We're still emitting these tracing and metrics data, but we've also added an error rate of 0.2. So about 20% of requests that hit the API server are going to fail. And so this will allow us to be able to see tracing details when there's an error. And then we've got our API proxy Envoy sidecar running there, just configured the exact same way as the others. And then we're also running a Datadog agent. And so this is running to collect that data and actually ship it over to Datadog so we can see it in their dashboards. And then we define a custom network for us so that we have a network to work within so that we can have all these static IPs without any overlap. So now let's go ahead and bring this all up with Docker Compose up. And so this is starting all of our containers. And now we can see they're all started and we're getting our logs from them. And so we see all the logs from everything as they start and come up. So if we jump over here to the browser, we can go localhost 8500. Oh, where's my console? Consul's still starting, it looks like. All right, so the containers are still coming up, so they're not fully responding yet, it looks like. Uh-oh. It's always best doing live demos. Let's see real quick here. Make sure I don't have the wrong port real quick. Docker compose and scroll up to console. Yeah, 8500. Okay. Oh, I know why it's not working. I have to tell it I want the UI. Maybe. Oh, come on. Okay, well, let's see if we can access our application or if something broke entirely. Yeah. All right, so we've got our application running at least, and we can access that, and they're able to communicate. So console is up, just not sure why this doesn't want to load for me. Something's going on with the console UI there, but it is running. So I'll have to dig into that and figure out why that didn't work. But we can see we've got our ingress service, which is what we hit for this request. We've got our web service, which was gone to from there, and then our API service. And if we refresh a couple times, we'll see eventually this fails because about 20% of requests will fail. And so now we can actually start digging into all of this data that we're shipping to Datadog. So if we jump over here to Datadog, we've got our dashboard, and it's going to show. So we can actually come over here and look at APM and look at our services. And we'll be able to see that our services are now responding. And we've got our ingress service, our API service, and our web service. And then we've also got an Envoy service that represents all of our Envoy proxies. And we can see for each of these services what our error rates are, and we can actually drill into them and see more information as requests continue to flow. I think I can knock this 15 minutes, see a little more data. But as those continue to run, we'll be able to see even more data come through. And then we can also see a service map. And so this will show us all of our services and how they communicate. Since everything goes through the Envoy proxy, it is by far our largest service. And ingress talks to Envoy, which then talks to the web service through there. And then the web service talks through Envoy to get to the API service. And so it's able to build that all out just based on all the tracing data we have. So now if we actually dig in, we can look at some of these traces. And so now we can see all of these different traces we have. And if we dig into, let's start with one that was successful. We're able to see that the request came in and it hit handle request, which is the process inside of our application, inside of ingress. And then it made a call to call upstream, which talked to an egress Envoy proxy on localhost 9091, which then went to another Envoy proxy for ingress. And so from there, we can actually see on this one, we get all of the HTTP data. So we can see what the response size was when it was returned and any other information we want, as well as the cluster and HTTP parameters that were passed around. And then from there, our web application handled the request, and it followed that same process of call upstream, which then made a call to our egress. So we can see the egress received a post with gRPC here, and that our user agent was actually gRPC go. And then we can see where this was received by the ingress or by the Envoy proxy for our API service. And we can see all of the data here for that. And then we can see where we actually handle that request inside of the API service. And since there wasn't an error, all of these services also happen to have a built-in service delay function. And this just is to slow down the response and show how you can see all the different function calls that are being made. And so then when the request came back after call upstream, we actually called service delay here in the web. and it didn't make any external calls, so there's nothing under it. And then as the request came back all the way up into our ingress, we called service delay there. And these are just random times, so we can see how long things take. And with all this, we're also able to see metrics. So we can see when our trace was right there. We can also see what our CPU utilization looked like, load averages from our system when this ran, what memory looked like at this exact time, disk latency, network. So all of this data that would help you potentially figure out why something failed if this was a failure. So now let's drill into an actual failure. And so now we have one where it failed. And so one of the things you'll notice if we look in our application over here, when this fails, we just return a 500 from the ingress. We're not returning the error directly from the application at the API layer to the end users. So what the end users see is they just get an error processing upstream request at that IP address or that URI. And so that's all that's returned in the error message there. But as we drill down, we can see, okay, so in here where we handled this, we received an error in our web service that said RPC error, because we're using gRPC, and the code is unavailable. The description is service error automatically injected. And we're like, okay, so that gives us some information. Now we can drill all the way into the API, and we can see the full stack trace, and we can see errors were generated with an error string, and that is service error automatically injected. So we can actually see our entire trace here of what was happening. And in this case, we just hit the random 20% case, and so we threw an error. But we're able to see all of that data, as well as, we can see the metrics like I was showing before. But one nice thing is we have an errors tab. And this will show us every error that happened in the entire stack for this call in one screen. So we can actually see all of them in one place if we wanted to be able to drill into those more. And so now that we've shown this, let's jump back over here and let's go ahead and stop this environment. And while this is stopping, the next thing we're going to do is down just to go ahead and remove everything. So now close that one. So now we're going to leverage a tool that we built, some of our team built here, called Shipyard. And so this allows you to run cloud native deployments. So Nomad, Kubernetes, leverage Consul, leverage all of these things easily inside a local dev environment by specifying some HCL, and it'll automatically configure this for you. So let's dig into what this looks like. We can go ahead and close this tab now. And so now the first thing, we're going to define our Kubernetes cluster that we want to run this in. So HCL. And so what we did was we defined a K8s cluster, we call it K3S, and we're using the driver for K3S. This way we get a really fast, lightweight Kubernetes cluster. And then we're going to define a K8s config for what we're going to call app. We're going to use our K3S cluster, and we're going to use Helm console. So we're going to say that that's required before this continues. And then we're going to also pass it this directory, and it will just apply all of these kubeconfigs for us. But since we have wait until ready, it won't apply these until our Helm cluster is online. So let's take our Helm deployment is done. So let's look at our Helm deployment now. And so Helm, what we're doing with Helm is deploying Consul. We're deploying it into that cluster with the chart Consul Helm 0.16.2, and we're giving it the values file. And so this is exactly like what John showed just a little bit ago, where we have a values file. And so let's go ahead and dig into what that looks like. Oh, and before that, this is the health check we use, so that up here where we're depending on this, we can actually use this health check, which will be any pods that have release equals console. So those have to go into a ready state before this deployment is considered done. So now Helm console values. And so this is our values YAML file, like what Jono showed, and this will overwrite any values that are defaulted in the default values, but those values will still be used if they're not overrun. So we just enable everything, one replica, one bootstrap. We start our clients, we bring the UI up, we enable a service for it. And so we turn on connect inject. So this is our injection sidecar. We turn on central config because we're going to leverage that. We set our default protocol to TCP. Then we define some proxy defaults. So we're going to tell Envoy proxies to run Prometheus and listen publicly available on 9102. And then we define the same extra static cluster JSON that we defined for the Datadog demo. So we've got JSON in here, so it doesn't look as pretty because it has to be escaped. But this is going to go to a service called Jaeger collector. And then we've got our Envoy tracing JSON, which tells it for the sidecars, send all of your tracing information to the Jaeger 9411 cluster and use this endpoint with the name envoy.zipkin. And now we can actually show our ingresses real quick. So here we just define all of our ingresses so that things can be publicly available. And we can actually tell it to open these in the browser for us as they come online. So we just define all the services we're starting. And now the last pieces are the Kubernetes configs. So we've got our application. So this is like what Jono showed. And so we've got our service for our web, and then we've got our front end web. And you can see here we actually are using the connect inject true, the connect service upstreams or API, but then we also add a connect service protocol of HTTP. That way connect knows that this service talks in HTTP. Then if we scroll down, we're also setting our tracing for Zipkin to use Jaeger collector, which will be the Kubernetes service. And then we've got our API service that we're going to go ahead and define. It'll be very similar to the same thing, specifying service tags, and the connect service protocol is HTTP. And so this runs, and it's also got the tracing Zipkin defined. So now let's go ahead and bring this all up. So shipyard run dot. And so this will start shipyard, and it will start all of these services for us, including creating our Kubernetes cluster, defining the network for it, bringing online the services that we had, as well as opening our browser automatically for us to the pages we asked it to. So this is starting. So as you can see, it's using K3s from Rancher so that it can actually create our cluster. So this is going, it only takes about a minute. So this will, so this part takes a second because we're waiting for all of the Kubernetes components to start, because we're creating our own Kubernetes cluster from scratch here. And so this is really useful for dev environments where you can do this. I see one question about, do we need to talk to the API through gRPC? So in this case, depending on which part, for the Docker Compose file, the API service was listening in gRPC, but here in the shipyard demo, the API service is actually running as an HTTP listener, so we don't define it as gRPC. So here we can see this is doing our Helm deploy for Consul. So we're just waiting for our Consul releases to come up. And so we can see here, here's our Consul service application. And we can see that our API and our web services are now available. Sidecar proxies have started. They're not quite passing health checks yet. It takes them a second. And we see Jaeger's now running. But if we watch, these will start passing health checks momentarily. So we can actually see here, we've got our fake service running and the web service can talk to the API. And if, we can generate a bunch of requests to see that. And then now we can see all of our services are passing health checks for this. And now if we dig into Jaeger, we can actually see over here, we can click a service and we can say, show us our API service and show us all of the results that you have. You can see here's one that just happened a moment ago. So we can dig, oh, before we dig in though, you can actually see there's one request to API, one to API v1, or sorry, two to API v1, and 4 requests to the web service within this. And so what happens is the web gets handle requests, just like we showed in Datadog, and then we call upstream. And then this actually makes the call over to our API services. And unfortunately, it looks like the Envoy sidecar proxies for these services started before Jaeger was started. And so if we actually jump back over here, we can actually fix that. So that's why we're not seeing Envoy in our, we're not seeing Envoy in this request stream because the order that these all started. But, okay. Oh, the Kubernetes clusters aren't. Oh, darn. Okay. But once those restart again, those will start responding and sending their metrics over. But I'm about at time now. So with that, I just want to say thanks. And we will make sure I get these Datadog Kubernetes examples and the Jaeger Kubernetes examples added to the GitHub repo on observability within Consul so that you can actually deploy these and try them out yourself. And with that, I'll hand it back to Peter.